In this example, we're going to look at a problem that wants us to factor by grouping. Our dead giveaway that we're looking at a factoring by grouping problem is that the problem has 4 terms. When we see 4 terms, a lot of times we can take advantage of grouping. Not always, but if we try to do that here, what we're going to do is we're going to group the first 2 terms together. So I'm going to look at that part of this problem right now, and only that part of the problem. So put the blinders on for a second. Forget about this part over here altogether. Just look at that piece right there and say, is there anything that those 2 terms have in common? So it basically becomes a greatest common factor problem. And I look at x to the 3rd power plus 2x squared and see that there's nothing in common between their coefficients other than 1, so that doesn't help me. Looking at the variables, when I see x to the 3rd power and x to the 2nd power, I can factor an x to the 2nd power out of each one of those. So this should equal x squared times the quantity. And to figure out what's remaining, again, we're just going to divide by what we factored out. X to the 3rd divided by x squared. Remember, you subtract your exponents from your exponent rules from Algebra 1. That would just leave you with x. And 2x squared divided by x squared, the x squareds would cancel out, and that would leave you with x plus 2, like that. The next part of this, we're going to look at the second 2 terms. So just kind of focus on just those 2 terms for a second. And we're going to try to factor out a common factor from there, trying to make what's left over match what's in the parentheses here. Since I have a different sign pattern, it went positive, positive, and then these next 2 terms switch it up. It goes negative, negative. It was the opposite of what I had over there. I know I need to factor out a negative number to kind of deal with that. Looking at the numbers 3 and 6, the biggest number that could go into both of those, the greatest common factor there would be 3. So like I said, I'm going to have to factor out a negative 3 to take care of that sign pattern issue. And that would leave me, again, with just x. Again, if I divided this by negative 3, it would just be left with the x. And if I divided negative 6 by negative 3 to figure out what would be left, negative 6 divided by negative 3 would actually be positive 2. You can always check it real quick. Does it distribute back in to give you what you had? Negative 3 times x is negative 3x, and negative 3 times positive 2 is negative 6. So I know I haven't made any mistakes with the factoring. Hopefully, at this point in the problem, you look at what you had left in the parentheses here, and you see that those are the same. If you do, you're in great shape. Now we're really visualizing it like this has 2 terms. Here's the first term, and here's the second term. And when I look at those 2 terms, I say, well, what do those have in common? And I see that they both have this set of parentheses with the x plus 2 in it. They both have that binomial factor in common. Just like before when I was factoring out common factors, I took that out front and wrote it down once. So I'm going to do that. I'm going to take the x plus 2 out of each of these terms. So I've taken that from each of these, I've put it out front. And then what would be left here if I took its x plus 2 away? Well, I would just be left with the x squared. And what would be left here if I took its x plus 2 away? I would just be left with the minus 3, like that. And I've completed this problem factoring by grouping at this point. I have a linear factor here, I have a quadratic factor here. But this is not going to break down using any of our traditional types of factoring that we've been looking at. Sure, I could technically factor x squared minus 3 as a difference of squares if you wanted to use some radical expressions in there, but I don't need to worry about doing anything like that at this point. So, it's an overview of factoring by grouping.